let's continue on here. Average rate of change versus instantaneous rate of change. Okay. Oh, goodness. That isn't stroked out. It's supposed to be underlined. Oh, Mr. Sadler. I'm sorry. I'm trying to go too quick with it. There's a lot of good stuff there. Okay, this is diagram 2. This is our last diagram today. I'm just going to draw any old parabola there. I'm going to pick a point P. Okay, now this is where we got to start thinking a little bit deeply, not horribly deeply. Let's get that scribbled down and then we'll come back to this. Wait till we get to trade. I can't draw a triangle to save my life. Don't laugh, Ron. If you've been in my class, you know it's true. Okay, this is where we got to start thinking a little bit deeply. What are the coordinates of point P going to be? If this equation is f of x, if this equation is just called f of x, what's point P going to be? What are the coordinates of P going to be? A is your x value. What's your y value going to be? A and f of a. Okay, we're okay on that? Where that came from? Okay, I'm going to call then some distance this way. I'm going to call that distance there h, going across it.
It's perpendicular to?
Perpendicular to the x, not to the x range there. This is going to be point Q. Can somebody try and be brave here? For point Q, what's the x coordinate going to be here? Plus h, wonderful. Right? So if that's h, this is just a plus h. We're okay on that then? A is the first point. H is just going to be going across. So it's a plus h altogether. What's the y coordinate going to be? A plus h and f of a plus h. Okay. This is the other thing that's difficult. What is that green line going to represent? This is where we're going to turn our math names on. Everyone else for Liam. You're out, sorry. Okay, because you probably didn't know the front from last year. What's that going to be? What's that height going to be?
The difference on the x values between Q and P.
Not difference between the x and the y values. So what is the difference of the y values between Q and P? Yes, good. Lovely. You know, great. You guys are. So what she said was f of a plus h minus f of a. Right? So it's the y value of Q minus the y value of P is going to be that green line there. Okay? Now for some fun. As if that wasn't fun enough. Can someone be brave and tell me the slope of line PQ? What is the slope of line PQ going to be? Michael, go first.
F of a plus h minus f of a.
That equation, which we just got in here, is called the difference quotient. The difference quotient is given right here. Is the slope of the sequence, let's try again here, is the slope of the secant. Between points P, A, and F of A, and Q, A plus H. Okay? Remember, H is the difference between the 2 points in the x variety. Let's talk about instantaneous rate of, so I'm going to take a step back here. Please ask questions. We're just sort of making the logic where this comes from. We're sort of going to prove things as we go to where these actually come from. You know, is this looking somewhat familiar? Not at all. That's okay. It's been a year. It's been a year. I'm not going to build you anymore. It's all right. It's good that you're coming in. This is a good thing. Okay, so we're looking for the secant between 2 points. How would I find the instantaneous rate of change? What will have to happen for this to be an instantaneous rate of change? Oh guys, don't give up. Where's Spider-Man? Liam, you're out. Hatcher. If something is an instantaneous rate of change, what is that? Of what? Well, what is instantaneous rate of change? The slope of what? Yes, but what key line? He's missing one key word. Tangent's the word. What is a tangent? Yes, good. But the point is that there's only 1 point, right? So what's going to change in this if we're finding the slope of a tangent?
If it's not really going through 2 points.
Right, it's only going through 1 point, so h is going to be half. 0 is what I'm hoping we say, right? Because what's going to happen, this is how calculus works. Instead of the range going from here, then it's going to last until you're just dealing with a single point, right? So what's going to happen for instantaneous rate of change? We're done our definitions after this. It's just examples after this. This is the slope of the tangent. At a single point. As h approaches 0, the slope of the secant, gets closer to the slope of the tangent. I'm going to pause on the video and then I'll let you guys ask questions if you need to.